And so that's my total ionic. Next step, usually to me, the total ionic is kind of a throughway to get to the net ionic, but let's cancel spectator ions, which are AQ on both sides. What's aqueous on both sides?
You might just keep the H2O.
I'm going to keep the H2O, but what can I cross out? Can I cross out everything over here?
The Na.
Yeah, I sodium aqueous on both sides. What else is aqueous on both sides?
SO4.
The SO4. So that's all I'm going to cancel. I'm not going to cancel everything aqueous because this thing is not represented as aqueous over here, right? There should be a 2 right there, right? I forgot that. I got excited.
Excuse me, I have a question.
Yes.
When you end up with aqueous in both sides, like there's like, let's say there's no liquid in this example that you're working right now.
Yes.
What happened after that?
So if everything's aqueous, then everything will cancel. I can do an example of that if you'd like.
Yeah, please.
It will never happen with an acid base. With an acid base, as we've defined it, you're always going to make water. I call it the null set, where everything cancels. Magnesium chloride plus sodium sulfate. So this breaks apart into magnesium 2 plus 2 chloride minus 2 sodium plus SO4 2 minus. So when I swap those, I'm going to get magnesium sulfate and sodium chloride, right? And then after balancing, I'm going to see I have 2 sodiums here and 1 there. I'm going to put a 2 here. And if the reactants were given to me as aqueous, and I believe magnesium sulfate on our solubility table will be shown to be aqueous. Actually, does someone want to look up sulfate? What's the rule for sulfate? But anyways, when I go to write this, so this is my balanced equation. When I go to write my total ionic equation, everything becomes ions. I get magnesium 2 plus aqueous plus SO4 2 minus aqueous plus 2 sodium plus aqueous. I'm kind of ran out of room here. Plus 2 chloride minus aqueous. And everything cancels. All of it's gone. So let's do it. Magnesium with magnesium, chloride with chloride, sodium with sodium, sulfate with sulfate. So this case, so you do want to have an answer. Your answer is no reaction.
Okay, because that was the when in the worksheet of precipitations there was like there was reaction or no reaction, and I was just putting on the line no reaction when I ended with everything cancels. So that means that that's just a solution, or?
Yeah, so I'm mixing 2 clear things. Okay. I have 2 liquids, and I mix them, and there's no neutralization, so I pour them together. Here we go, into one thing. And so this has magnesium ions and chloride ions floating around, and this one has sodium ions and sulfate ions floating around. And when I mix them together, I just have all 4 of those ions floating around. There's no actual reaction happening. Okay. There's no change. Sorry.
Okay.
Plus sulfate 2 minus. There we go.
All right.
So that can happen. Everything's soluble before and after. And so for whatever test, I would give you a solubility table, or that kind of information would be given in the problem if you did not have a table.
All right. Thank you.
Yeah.
On the worksheet, when it says include the states, it's only going to be aqueous or solid, right? Unless noted.
Well, actually,
Pick 2.
liquid. So the ones that don't cancel out, let's don't cancel liquid, solid, or gas.
How do
And
we
so,
know if this liquid or a gas?
okay, so the solid's going to come from the solubility table, like you mentioned. Solubility table. The gases may come from a gas forming reaction. And so for those, you have to memorize. There was only one that I wanted you guys to know. There's only one gas forming that I covered. I can do that again. The liquids will typically come from an acid base. Neutralization, like we just did up here.